welcome back to another episode of Bone Apple Tea. On this week's episode, I pretty much talk about me.
This is Adam's highlight episode.
Yeah, so pretty much we talk about electrical engineering and kind of, I guess my journey, through high school, college, and my job now, and kind of what translated between college and grad school, and then grad school and college to actually work life. Yeah,
and I asked Adam to do this episode because I thought it would be really helpful for anyone who's considering either engineering or specifically electrical engineering, kind of like what actually matters, what's helpful, his own personal experience, and then kind of like everyone's biggest question coming out of college, which is like, well, how is what I've learned in college actually applicable to my job? Mm-hmm. So, you'll get to hear all about that on this episode. The weekly slap is Vitamin by Vacation and YungxHarm.
Nice.
Sweet.
Enjoy.
So I do want to talk about
What are we talking about?
So I want to talk about the difference, or not so much the difference, but how and we'll talk about specifically electrical engineering because you happen to know a lot about electrical engineering because that's what you got your degrees in and it's your job. So I figured we would have a whole episode where we just it's your job.
Oh shit.
Where we just kind of break down the expectations from high school into college into grad college, and then grad college to job, kind of like how that was for you, and pretty much like the expectations versus reality, maybe, of what it's like to be an electrical engineer.
All right, cool.
So some of the background. College, man. It's kind of crazy to think about because the fact that it was, for us, rounding up on 2 years ago.
Yeah. I mean, 2018.
Yeah.
2018 we graduated college or master's.
Yeah, master's was
we graduated undergrad.
Yep, undergrad.
Speak.
And then our grad school was 2018 was the graduation there.
Yeah.
And so, I mean, literally, we're rounding up on what would have been the end of our grad school year into our actual career 2 years ago. So it's been a little bit, but I want to talk very quickly, like the expectations from like you in high school. I can talk a bit about me too, but like coming from high school into college, you had kind of a unique switcheroo.
Oh yeah, I didn't. It's kind of funny. It's like an interview kind of.
Yeah. It's like an interview for you, but
I didn't actually come into. I didn't go into UConn as an engineer. I went in doing like physiology and neuroscience or something like that, which they didn't offer at UMass. So that's why I went to UConn. It was like the whole New England regional tuition, so it was kind of a substantial cut. It was basically in state, but not exactly.
Right.
But anyways, yeah. So I came in as like PNB, and then for whatever reason, I don't know why, I was like, I wanted to go to med school, and I was like, I'll do BME because, I'm good at math, and like it'll look good on whatever if I come in with an engineering degree going into med school. And I think a lot of people think that same thing.
Right.
Which is, it's true.
Yeah.
And there's physics and math on the MCAT, and a lot of our friends that went to med school hated that stuff. So it was good to be familiar with it anyways, because we do way harder stuff in engineering major than what is on the MCAT in terms of math.
Yeah, no, for sure. Yeah, because that's not their focus. So it works out that like you're well versed in that, because that section, which is usually the harder part, is actually a breeze.
Yeah, exactly. So I was like, all right, I'll just switch colleges, which like apparently is kind of like a bigger deal than I thought it was going to be. But at least that's what people when I got to the school were saying. But like I called the day before we actually went in to pick classes and stuff. And then and I was like one of the last dates to do that. So it was very close to this actual start of the semester. And so, I was just like, hey, I want to transfer to, BME instead of PNB. And they were like, oh, well, you're switching from a liberal arts college to the engineering. So we have to like reevaluate your whole thing or whatever. Like, what did you get in physics and math? And I was like, yeah, here's my transcript. And then like literally an hour, like 20 minutes later, not even she just called, this woman called me back and was like, all right, yeah, you're in. I was like, all right, cool. So it wasn't.
That worked out.
Yeah, it wasn't like a big deal at all. But everybody I know that transferred from colleges, like within the school, once they got there, it was like a giant pain in the ass. So
I think you just happened to luck out.
Yeah.
Stars must have aligned for you at that moment.
And I didn't even think I was going to I was more into chemistry and stuff. It was more so my like my wheelhouse was more chem and math, I guess. I didn't really like doing electrical engineering now, but I didn't even think about it. I knew some stuff just because like my dad's an electrical engineer. He's got a doctorate in computer engineering, so like I've learned stuff just from him and just like messing around with things at the house.
So was being an engineer ever even a thought in high school?
No, I never even thought about it. I wasn't even like, there was no desire there. I was like, yeah, I'm just gonna go to med school and be a doctor and like it'll be cool. Which like, I would randomly go and do that now. It still kind of looks like fun, but at the same time, it's just like different than what I wanted to do because, I don't know, you get to school and it's like completely different.
Yeah, it is. And so actually, like, what was it like in early college? So you switch and you go from, friggin' you're switching out of this sort of like, I don't want to say med school mentality, but you still had this idea that you wanted to go to med school. Like, when did that even like stop? Did you start taking classes and you're like, oh, I don't know, being an engineer is kind of cool?
It was like, so like I was doing a bunch of stuff for med school. It was like a bunch of like extracurriculars and stuff because you have to be involved in everything and you also have to have perfect grades and stuff and whatever. Yeah. So the first 2 years, I mean, it's just basic classes. Everybody takes the same thing.
Yeah, it's true.
I still kind of like, we had our engineering 1000 class and we had our whatever 1166 classes and it was cool. I did fine. All the classes were super easy. So at least like the intro classes.
Yeah, it's the ones that's like, this is engineering. These are all the different types of BME.
Yeah. There's like a stark contrast between the workload, from the workload in high school to like the workload in college. It's definitely a lot more, but
yeah, like a lot more. That was the one thing I noticed is like in high school, I felt like, I had to do some studying if I wanted to get like some good grades, like some really good grades, but I knew that I could get a good grade like just by studying.
Yeah.
Whereas like when I hit college, I did the same stuff. And then all of a sudden I was like, oh, I got a C. Oh, I got a B?
Yeah.
Like what? I have to put that much more effort to get like an A? Like, oh my God, this is way harder.
Yeah, it's like a lot more stuff to take home too. And I don't know. I just like, I had taken 2 AP classes in high school, like, and for whatever reason, I didn't take the AP exams because I think I just didn't sign up because like that's just something I would do is completely forget that I had to sign up for these tests.
That is such a you thing to do, dude.
So I came in and I had to take Calc 1 and I had to take...
You had to take Calc 1?
And I had to take Chem 1. Yeah, I did. And Calc, which, okay, I mean, obviously, like I didn't go to a single class because Calc 1 is like the easy... Well, if you haven't... I already took it. And also, Calc 1, I think subject-wise, is way easier than like pre-calc even. When you take pre-calc, you learn about trigonometry. And it's like a whole thing.
I agree.
And Calc 1 was like here's the derivative.
Yeah.
Every single thing you do is here's the derivative. It's the slope. How do we find the max? Take the derivative because the slope is... You know what I mean?
Yeah, you're right. It is very much like a straightforward thing.
Everything is like, oh, well, if you take the slope and it's 0, then you know this. And if you take the slope and it's this, then you know what I mean? So
it's very... You're right. It's very like you have a very small set of tools that you need to use in order to solve every problem on the test.
Yeah. And it's like, I don't know. There's certain things where it's like, oh, you're taking a derivative of something and it's not straightforward because you have to do all these different, special things you learn.
Yeah. And there was only so complex that would actually go with that though.
Yeah. It was the second time I was going and, or doing the class because I took it in high school. So I came in and I was like, okay. And I didn't show up to anything except for the
tests.
The tests and then like the final exam review session. Actually, this is kind of funny. This has nothing
is this
to do
is this with you and Will?
Yeah.
Oh god.
Yeah. So like I showed up to the final review session for this calc class, like before the final exam. And me and a bunch of my friends, because we didn't go to class, so we were like, oh, we should probably show up, right? Like for the final review, maybe we'll learn something. I don't know. I wasn't worried about it, but I was like, just for, because it's a final exam, like we probably should show up.
Be a good student. Show up. See what's
so
up.
like we went and like, we're like, oh man, we're going to be late. And on the way to the class, we were going through the union. So we're like, oh, the Blue Cow, let's get some milkshakes. And my friend, I think it was Dan, Toy.
Oh, okay, yeah.
He was like, dude, we're going to be late. I was like, who gives a shit? No one's going to show up anyways. Who gives a shit? We'll grab some milkshakes. It's fine. So anyways, we show up and we come in through the back door of the class, which is like, it's like an auditorium style. You know what I mean? So it goes up.
Do you remember which room it was?
It was the class we had 1166 in. It was in that.
Okay.
It was that shitty place that we had a ton of classes in.
Yeah, I know what you're saying. Is it the one that's like like it's very vertical right off the bat?
I don't think so. What was that building that was like across the street from North? Like we had like chemistry in a very similar building. Was it MSB or something?
Yeah, MSB. Yeah.
Anyways, it was like classes. A big lecture hall in that building, and it like we had a ton of classes in there. And anyways, yeah. So like. We showed up with and we're coming from the back of the class. So we're up top, we come into the auditorium, and first of all, the place is fucking packed, and we show up so late, and it's dead quiet, and the door is so loud. So we bust in, and we all have milkshakes in our hands. We look like a bunch of assholes, and everybody turns around and like looking at us, and then the woman in the front just like looks up for a second, and then they go back to what they're doing, whatever. And we're like, all right. So like, and there's every single seat is taken except for 4 seats in like the front row. Like off to the right. Of
course.
So we walk down, dude, and they're all the way at the end. So we're like, oh, excuse me. We got milkshakes and shit. So we're like, oh, whatever. And then 5 minutes into the thing, I was like, okay, yeah, this was a waste of time. I don't know why we came here. I'm already bored. So I pull out my tablet because for some reason I was like, yeah, this is a good idea. And I open up a game to play. And it's that game Robot Unicorn Attack. I don't know if you ever played it, but it's got like the most obnoxious theme song. It's like this guy singing like, always I wanna be with you. Anyways, it was on full blast. And like the classroom was dead silent. And so like, dude, and it wouldn't turn off. Like I locked my tablet and it was still playing music. So like I freaked out and threw it on the ground.
Yeah, I'm gonna get the song. Yeah.
So like, I'm playing it, and then like it starts making noise. Everybody fucking turns around and looks at me. I'm like, oh, and I toss it on the ground, and I'm sitting there, fucking Dan and Will, people next to me, just like put their faces down in their lap, and I was like bright red, just looking around like, dude, yeah. Dude, this is in the middle of a lecture,
and you're the guys that showed up late,
dude.
And you're the ones with the fucking milkshakes, and you had to scoot by everyone in the fucking front row,
dude. Yeah, it was, it was embarrassing as shit, and whatever. I got an A in that class, so I don't care. But that, anyways, yeah, that was a side tangent. I forgot about that, but that was interesting.
God, that's wicked funny. So are there like stuff from the intro classes that you thought were really pivotal towards like your engineering career? Like I remember, like, because I had to take some of the intro level classes for like there was kind of electrical engineering based, and like one of the biggest things was like V equals IR. That's like one of the biggest concepts because that applies to like every circuit that you're trying to solve. When you all boil it,
that's like literally everything I do is like it ends up being something like that. Like, okay, well, at the end of the day, V equals IR. So what are we doing here? You know what I mean? Like, make sure that this is satisfied. But I feel like when you learn it, it's initially it's like kind of weird because like I don't know. The more that you use that equation, it seems so simple. It just starts to make more sense. It's not like well, just real quick to answer your question, I started thinking about doing engineering and not med school stuff when I was when we took ECE 2001. So when we took the ECE course over the summer.
I remember that.
And
it was a great class.
And signals and systems, and I was like, oh, this is cool. Like this is fun as hell. And we were doing the labs, and I thought the labs were really cool.
Yeah, we made that the 3-band EQ.
Yeah, exactly. And like I actually understood what was going on based on the equations we learned in class. So because I actually spent time on them.
Yeah, I remember.
So it was really cool.
Weren't we on a team together?
I think so, yeah.
It was like me, you, and Cam. Yeah. Was that the first start of me, you, and Cam?
I think so.
Holy shit.
Yeah, it's funny.
That is funny. I remember like we had made the EQ, and then you went like all like neat with it, and you like cut all the wires to be exact lengths and stuff.
Yeah, it was I still have it actually. It's at my house.
Oh, really?
Yeah.
That's hilarious, man. That's so funny. Wow.
Yeah, so we made that EQ, but that's when I was like, like electrical engineering is pretty cool. So I kind of switched over because I was taking a lot of chemistry related classes.
Okay.
Talking to a lot of chem professors because that's kind of what I was trying to do research wise.
Right.
But then I got into, ECE stuff. And what was the second question you asked me?
It was more so like, were there stuff from the beginning that you thought like, maybe you didn't even notice that like, I'm just going to skip over this because I don't really care, but like probably would have been helpful had you like, maybe thought about more of like, this is actually really important for later classes.
Something
like that.
There's like, all of the fundamentals really, like the basic equations. So like when you go later on, you end up having like all these equations like for current and whatever, it depends what you're looking at, but like current and voltage, and as they change with respect to time, so they become like a dependent equation as opposed to something that's just like V equals IR
Right.
isn't a time dependent equation if you look at it like that. But it can be. But like, you
Yeah,
don't think when you first get the class, you're like V equals IR.
Right.
And everything's discrete. So like you're analyzing circuits. You're not designing circuits.
Right.
Which is
Okay.
different. But you need to know how to do analysis so that if you want to make something, you
intelligently make it.
Yeah, and then you can analyze it afterwards and make sure it works. But
Okay.
that's why we have things like simulators now.
So then what was the difference between like the low level classes versus like the upper level classes? Besides just difficulty.
Well, complexity for sure, but
Mhm.
okay, well, I should say actually, because this just came to my head, but fundamentals that kind of help. It's weird, but like this is, I don't know, it's like fundamentals, but like physics 2, even though like that class was hard as hell, but everything in physics 2, like all that electricity and magnetism stuff.
Dude.
I
remember studying like that with you for the physics 2 final.
Dude, yeah, it helps a lot with like conceptual understanding of how electricity and magnetism works. And so if you're trying to solve a problem, and regardless of the electrical engineering knowledge that you have, because that's like, okay, here are the components and I know how to put them together. It's like you can kind of think of it as like physically, this doesn't make sense. Like because of physics, I would expect this to happen. And so it makes debugging a little easier. So it's really like fundamentals and conceptual, like large scale conceptual things that help a lot. So it's like, and things like math, like all the math classes you take and things like linear algebra, it seems so disconnected, but it's actually
Did you take
super
linear?
important. Yeah, I ended up taking it.
Oh, see, it's funny. I thought about taking it and I didn't because I think I ended up taking a SolidWorks designing course or something.
Dude,
instead.
well, it's all matrix math, and everybody, and so and that's super important. Everybody ends up doing it, and you know what I mean. So like that, and it just helps with if you ever want to get into more like I don't know. If you want to get crazy with design work, you want to do more intelligent designing, and you want to do something like you want to design filters or something like that. You kind of need to know. You need to be good at math. You know what I mean? Like you really need to be able to understand the math, and you're not going to be able to learn all of the math associated with it if you don't have a good foundation just in math principles, because there's patterns everywhere, and if you are able to recognize them, it makes it way easier.
Yeah, and I feel like I remember seeing like linear algebra homework, and I was like, you know what? I like really wish I took this, because even in my courses, when it came to doing like coordinate transformations and stuff, that's like linear algebra 101.
Yeah,
that's like basics in linear algebra.
It's all matrix math, and it all relates. You know what I mean? All the whole coordinate system translation and stuff. Calc 3 was another big one that was.
Oh yeah, I liked Calc 3. I had a good teacher.
Yeah. Calc 3 was great. I had a good teacher too. It was really hard.
Could your teacher draw really well in 3D?
Yeah, he was pretty good. I feel like that's kind of like a prereq for a Calc 3 teacher. Yeah, you can't be a Calc
3 teacher without because this guy was like he'd be like he was like a 3D artist is what it felt like, even like for a math teacher, mind you, for a math teater.
Yeah.
But like
still, you got to be. Yeah, you're drawing figures all day.
Yeah, that's literally everything was like a figure of some sort.
Yeah, but I think the biggest difference is like more like you can get into crazier concepts because you've already taken the lower level classes. That's like, these are the fundamental rules. And then it's like, look at all the crazy shit we can do.
Now that we know the fundamental rules.
And you have to know them well enough that you don't really have to think about it. It makes the higher level classes a lot easier if you don't have to think about the fundamental stuff because you know it so well. So like you can intuitively understand something because you understand that based on these fundamentals, you can, basically say like we can arrive here based on what we know.
Right.
So, but that's it. Like you get into things like, I don't know if you remember we did like sequential switching and stuff where we had a bunch of circuits and they all store and release energy, but they're not connected to each other. And you say, oh, this switch switches at this time and this switch switches at this time.
Was that in Kumavar's class? Did we do that?
I don't know if it was in that or if it was just in ECE 2000.
Oh, maybe it was the second.
Maybe like the end of it.
Yeah, like something like, because I do remember like time switching and like this would like flip on a switch and like it would impact the circuit and like close off another section and all that.
Yeah, it was a lot of we might have done something like that, but it was a lot of like capacitive inductive circuits being switched. They store energy. So
you're right. You're right. And then you could view it as like a broken line, right? Wasn't that like one of them too? It was like,
yeah,
I forget what
so. That was a piecewise. I think that was actually a mechanics
Was it?
Yeah, because we did something similar where it was beam analysis, except it was broken up portions, and we did a curve. It was actually a pretty similar process. It was just a
Really?
beam analysis.
Wow, I totally forget that.
Yeah, with multiple like.
I wonder if I'm thinking of beam analysis and I'm not thinking of electrical engineering.
You could be, because it was a similar process math wise. It was like you break it up into steps like T0, but instead of time, I think it was lengths or something like that.
Yeah. Wow, that's wicked funny. And the math was very similar.
Yeah, it was. It was super similar.
So let's talk about senior design a little bit. So we were on the same senior design team, but quick summary of what senior design was. We can jump in both on this one.
I mean, well, we pitched an idea. So it was a ultrasonic a localization device, pretty much, just for blind people as an aid to help them navigate.
Right.
So
we called it the navigational device for the visually impaired.
Yes.
I remember.
Yeah. And so more or less it was a series or a set of ultrasonic transducers, and we would have one that would transmit and three that would receive, and they were in line with each other, and it was a belt buckle worn device. And basically it would triangulate objects based on bunch of equations we had derived, converting from, is it polar coordinates to rectangular?
I actually thought in the end we kept everything rectangular, if I'm not mistaken.
Okay, because I think the way that we had it was like,
but you would remember more because you did more of the programming.
We had an R and a theta, because that's what the output of the transducer was. It was a radial measurement.
Okay.
It wasn't a like XY coordinate.
You're right.
So
you're totally
the thing scans in like a beam pattern. It goes out like
almost like a cone. A cone with like an arc on the end of it.
Yeah, like an ellipse on like the bottom face of the cone.
Yep.
And then basically you'd get a radial distance, and then we would take the radius and the angle, which we did some triangle math to figure out the angle using all the it was basically like triangulation is what we did.
Yeah.
And based on the amount of transducers, we could detect a certain amount of objects.
Yep. And then pretty much based upon how far away the object was would indicate how much a wearable strap of like a grid of vibrating little buzzers, and they would buzz more intensely if the object was closer. And then our next step was we had an array of them, and they pretty much would buzz depending on the location. So if it was on the left side, it would buzz mostly on the left. But it was actually accurate enough to the point where it was on this grid so that like if an object went across your field of view, you would feel it slowly translate across your body.
Yeah, exactly. And we had like a whole setup when we were displaying it with the oscilloscope showing the waveform being received and being transmitted and stuff.
Yeah, that was really cool.
Yeah.
And we ended a little small flex. We ended up getting second place.
Baby flex.
Yeah, a little baby flex there. Second place at our college for that. But
that was a microcontroller thing too, right? So the whole thing was ran by a small microcontroller board.
Yeah, and so I wanted to know, how did your classes prep you for senior design, and did it prep you enough for senior design, or did you kind of have to go out and do your own thing?
So I would say
our buddy Cam, by the way.
Yeah, so classes definitely did prep me for senior design. I think the more you put into the classes, the more it will prep you for senior design. So if you actually like take a initiative to try to understand what's going on and get the reps in, just so that you commit things to memory, because it's just like practice, right? You're like practicing, engineering,
right?
Doing your homework and shit, which I was bad with, but it doesn't matter because when we had to go make something, I would just figure it out.
Yeah.
So, but definitely do your homework.
The last minute machine.
Yeah. So don't advise it. I do not advise it. But basically, I took this microprocessors class that had like 7 tests, and it was like a bunch of lab practicals, and it was like the most tough class that I took because
I remember you talking about that class.
Dude, there was just so much stuff to learn, and the teaching wasn't exactly the best, and it's really hard to just find. That was the first class where I was like, this is so much stuff that I have to learn, and there's no real textbook. I have to just like figure this out on the internet.
Yeah.
And like, you know what I mean? It's actually kind of hard to find. It's out there, but it's hard. You got to kind of have to learn how to use Google effectively, really.
Yeah.
It's like, it's a skill.
Engineering,
because,
for sure.
Yeah, because like, there's a ton of references out there, but you don't know which ones are good ones. And a lot of the times it's like some foreign guy in broken English, especially with electrical engineering.
Oh, yeah. And the other thing is that like when it's so specific that like a lot of times if you search incorrectly, you're not going to get anything.
Yeah, exactly. And so this was that was a really tough class because there was just so much shit going on, and like I really should just spend more time in office hours, but it was just stressful because like we'd have a test and we'd have to go into an exam, and I didn't know that we were allowed to use the internet while we're taking the tests for the first 4 exams we took, so I didn't. And so like pretty much I didn't know that. Apparently that was a thing. But yeah, we had to basically take these like Arduino dev boards and write a bunch of code. We go basically writing code the whole time. But you have to understand how the microcontroller works and like voltage levels and stuff like that, and what they can actually do, what the hardware on it actually does. And so it gets very complicated. And actually, that helped a lot. And just understanding how pins work and stuff, because when we had problems in senior design, I remember one specifically. We had a problem with floating pin, and I put a pull down resistor on a line we were trying to toggle with a microcontroller, and it wasn't really working that well. And I put a pull down resistor, and like it started working, and then also put a capacitor between the leads of the transducer we had, and acted as like a mini filter, and it ended up helping a ton. Basically, is what happened. And I was like, "Oh crap, cool! Like I actually did something that I learned from class, kind of." And so, I mean, that's largely stuff though that I found online. It's just like tricks of the trade, you know, when you're using micros, the things you got to do. I would recommend getting some kind of book and just following examples, because it was a shit show.
Yeah, I think this is where books actually like really are almost more beneficial than the internet, because like if you buy a book that's either recommended by your school or like something that you can get a recommendation from a professor, or in your case, your dad, who knows a lot about like electrical engineering, books are awesome because it's not, first of all, it's not some random guy on the internet that might have like misspelled something, or like this has been edited and looked through. So it's good to actually have resources like that. Now, moving right along. Difference between undergrad and grad school. What happened?
Undergrad and grad school.
Yeah.
I feel like I learned a lot in grad school, comparatively speaking, because of undergrad was a lot of like, well, you got to learn this before you can learn this, and you got to learn this before you can learn this, and then finally it was like we graduated and I kind of knew some stuff. And then grad school was like, all right, now take all the stuff you learned, and then here's a class where you can apply most of that stuff in one class. So I took some information theory classes, signals and systems that we took in undergrad was super helpful. And like every other class that I took, that was a high level EE class, because the things you learn, like convolution and all the stuff that you learn, like Fourier transforms and all that stuff. You end up using it in a lot of things. Like first of all, in statistics, there's a lot of in like stochastic processes and stuff, and like a lot of high level statistics use convolution. So it's because it's all the same. It's like you have a distribution. It's a signal, right? You have like a graph, you know, some Gaussian curve, and you can think of it as a signal or a distribution. It's all the same shit. So.
Which is actually good to know, because I remember, so I knew I wasn't going to be electrical engineering. So when I took signals and systems, I did the whole like, all right, so I'm going to look at this for only this class. So I'm going to pretty much just do what I need to get a good grade, and then like poop out all the other information I don't need. So it's actually good to know that if you are thinking about electrical engineering, a class like signals and systems is probably going to be a good class for you to look at and pay attention to.
Yeah, you're going to have to take it if you're EE. Even if you're not EE, it's like the math is just used everywhere. So you might as well just learn it, because it's going to be super helpful.
I think even Fourier transforms are used like all the time in other sections of math too. I remember they were definitely in my FEA class.
Even Laplace transforms, you use them a lot. You use them in like linear algebra. We learned about them too. I'm pretty sure. Like even what's called. It's just they're used all the time in mechanical engineering. Remember we took that BME.
The human biomechanics class.
It ended up being helpful then. So
yeah, I remember that.
Grad school is just like a ton of more. It was like the workload was like the same, more, but just dense work. Like all the work was just more. Like deep.
Yeah.
So
we also did the grad school in a year thing too, instead of 2.
Yeah. So it felt like a lot more.
Yeah. Which compressed a lot of the classes all together.
Yeah. And then also like just like working in a lab at the same time, and like,
that's right.
as like a job for hours, it was kind of, it It was a lot of work. I think also underestimated the amount of coding I was going to have to do for senior design, and also just in like life in general and how useful it is. So like learning how to code, like C, Python, and MATLAB. I would say MATLAB and Python are just any engineer should probably learn how to do them.
I mean, I'm using Python to this day.
Yeah. And then MATLAB is like every engineer should learn how to use MATLAB, no doubt. Like 100% just learn how to use it. When we first took MATLAB, I was like, why the hell am I coding? I'm never going to use this ever.
That's exactly what I thought about. I didn't take that class seriously at all.
Dude, I made zero effort to learn how to MATLAB. Like literally
Same.
zero. And then later on, I was like, wow, MATLAB's super helpful and it makes everything way faster. So I just learned it. I sucked it up. And then I learned how to code in C. And Python is super helpful too. I think MATLAB and Python are two that people should learn. And then C also, if you're an electrical engineer, just get on it. If you want to do microcontrollers, you're going to have to know it. So
yeah. Would you say it was a good idea to do your master's in one instead of two?
Yeah. Well, yes, because I didn't want to spend more time in school, and also it was just like an easy like $15K salary bump in just a year.
Yeah,
so
that's what I
think it was worth it. I also learned a ton because I spent a ton of time in lab, and I met a lot of cool professors and ended up like reading a lot of cool papers. And you learn a lot from working in a lab because you're actually doing things. Like when somebody expects something to work, it's like nothing is as straightforward as it seems in class. And also, and yeah, we'll talk about it later if you're gonna ask me about work. But
yeah, for sure.
But yeah, I would say it's more so the depth of the stuff you learn about. Like I did a information theory class. It was like neuronal information theory, so it was neurons, but how they work electrically and how you can model them, and then also like information theory math and how like statistic analysis of neuron firing. So it's like a lot of things in one. It's like a lot of complicated things in one class. So stuff like that. I mean, that class was really hard too, but a lot of math. And I think the biggest difference is just like how multidisciplinary the classes are.
Right.
It's not like this is just a chemistry class or this is just a physics class.
Yeah, you're applying pretty much everything you learned in undergrad, potentially multiple classes all into one class.
Yeah, exactly. Yeah. It becomes like a chemistry / like electrical engineering / math class.
Yeah, I mean, even that neurological systems one that you were talking about, like that's a combo of like everything you learned in like bio and physiology, and then also your math, and then your electrical engineering class all in one class.
Yeah, exactly. And it's like high level statistics. It's like stochastic process modeling type.
Fuck grad statistics, by the way. That sucked.
Yeah, that too. That class blew.
Yeah, no help from the teacher. Okay, so getting hired, right? So you go through school, and the biggest question coming out of school is, well, like, how do I get a job? So do you feel as though going to school prepared you well for the interviewing process?
Okay, for the interviewing process, no. But for my job, absolutely. You're going to hear all these people nowadays are like, fuck college, I'm Gary Vee. But, like everybody's saying, fuck
you
this.
You want to go to college? You want to like your parents? Fuck your parents.
Yeah. Everyone's like, oh, college? Might as well light your money on fire. Okay.
Yeah.
Okay, that's true if you're doing something like, I don't know, fine art. And you don't have aspirations to like own a successful gallery, or like if you're doing it just because like, oh, art's cool, but you don't actually want to be an artist and realize that you're not going to be,
that's lighting your money on fire. I know what you're saying.
Yeah. But if you're doing engineering, which engineers make a decent amount of money, you get hired pretty easily. College is absolutely necessary or worth it. I shouldn't say necessary because technically you can get a job without it, but every single thing that I learned in college has been extremely useful in my current job.
Yeah, I agree.
And all those physics classes and chemistry classes and whatever, mechanics classes and math, dude, I use every single bit of it. All the EE classes, pretty much everything. I wish I took more classes. Like literally, I like every single thing I learned in college for the most part I'm using now. Because I work you're not like confined to just electrical engineering. I have to interface with mechanical engineers all the time.
Right.
We have to be, like they ask for our opinion on mechanical problems. We have things we need to move from place to place. It's a lot of mechanical stuff.
Yeah. Well, the thing is when you're an electrical engineer, the reason you have to work with a mechanical engineer so closely is because you're both building a device. And if the device isn't working for, you're confined to a space. Like, dude, you had a project where it got changed like 5 times.
Yeah, just the shape of the board, which is a huge change, by the way.
It is.
Like, I have to move shit around, and if there's wires, you know what I mean? Like, I wired everything through the board. So, but it's funny, yeah, because like it's a lot more multidisciplinary than you would think initially, and like even as like a what's it called? Like you just end up doing more than you would think. You know what I mean? Like from EE, work wise, you end up interfacing with a lot of MEs and like, I'm working on batteries now. It's a lot of chemistry. So I need to understand how the chemistry works too, just to have a better understanding of what's going on here, because maybe there's some weird constraint that I didn't know about until I realized like how it worked chemically. But in terms of the interview process, no, I don't think school helped with the interview process. It 100% helped with the job. The whole interview process thing is more so just like you just kind of have to be outgoing and just like aggressive. Like you should just be hitting people up. You know what I mean?
Yeah.
Like
applying
follow-ups, just apply, reach out to people that work at the place you're trying to get a job at.
Yeah, this is actually where LinkedIn ends up being a really good place to look into.
DM people on LinkedIn. You know what I mean? Just like stuff like that. So don't be afraid, because if people are applying for a job and you're the only one that messaged the hiring manager and you end up talking to them, then you know what I mean? You're obviously going to get
all of a sudden you're at the top of the stack.
Yeah. So it worked. In terms of interview process, like things that really stand out, I guess, if you want to bring this up, just like the research work that I did, because I actually had done something. Like if you can produce something and then say, like, this is what I made, and it's really good. So projects from classes, also internships if you get an internship.
Yeah, this is a good time to realize that doing a bullshit project just to get through it is not a good idea, which I've seen people do. Like, oh yeah, I thought of this thing that fills all the requirements, but it took me 2 seconds to do.
Yeah,
and I'll still get a good grade. It's like, well, now when you go to talk about that, when you're trying to get a job, they're going to look at that and know exactly that that's a piece of shit.
Yeah, like you want you to be able to explain what you did, and also like they can see your thought process, and also like what you're physically capable of doing.
Right.
And so going like just from an internship I had and a project that I had done, like something I'd built, I went to like the career fair and got like 6 calls from people. You know what I mean? It was like an easy, like I didn't even really like stress about applying for jobs, because I applied to a ton of jobs online, but I like went to the career fair and got like a ton of job offers just from talking to people, because I was like, hey, what's up, man? All you need, you know what I mean? For me, it was like, all I need to do is be face to face, and like I'm fine. I have all my shit. I've done what I've done. So I'm just going to talk about it, shoot the shit with these guys.
Yeah, this is where like getting good at just talking to people is very important. Like if you're going to be an engineer, you don't want to be so one-dimensional with just being good at the work, because people also like people.
Yeah.
They want someone they can depend on, but also someone that they can like go grab a beer with after work or whatever. You know what I mean? Like they want to know that you can work in groups and be around and not be weird.
Yeah, exactly. And communication is a huge thing too, because you need to be talking constantly with the job. It's like if something happens, you need to update the person. If you guys aren't on the same page, then it's just going to mess things up. Yeah.
Which I say, like, I'm not saying don't be weird. Like, if you're a weird person, like, go into that, but be confident with who you are, and don't be like, so like, dog with the tail between his legs kind of a person, because they don't like that. They like to see people that are confident about what they do. Now I will say, for me, I thought that grad school ended up being extremely helpful in terms of getting hired. Would you also agree with that?
Yeah, because it was another thing, because like I had to give a presentation and they wanted me to present on the research I had done. And it was all actually related, because I did a lot of sound related things. I actually helped a ton. Like literally everything I did in grad school was like somehow sound related. And now I work for an acoustics company. So you know what I mean? It was a very direct relationship. Yeah, how we made the sounds and processed them and stuff. And then what I did microcontroller wise and explained the whole schematic capture. And that's actually why they hired me. They were like, oh, because you actually had something, like you came with something that like you actually made.
Okay. So that was like the one, like as far as like your resume and candidacy, like that was the thing that stuck out.
Yeah, it was like you actually had produced something. That's what Jeff was telling me. He was like, okay, you actually had something that you had, produced, and you explained it to us. So that's like pretty much why we hired you. Yeah,
see, that's important. That's really good. Now, as of being on the job, we'll kind of close out with this. So you've been employed for about 2 years now, almost. What are some of the best things that have transferred from classes to applicable skills on the actual job? I think we kind of touched this, but we'll do a little summary if we can.
Yeah. So, I mean, like literally, okay, MATLAB, because it makes everything faster.
Right.
You know, even for simple tasks, like being able to process and move files, just doing batch scripts and stuff is just really like, if you have to, even something as simple as copying files over and there's a lot of them, you can literally write MATLAB. You can make MATLAB do that for you. Stuff like that. You know what I mean? So it's just like, okay, MATLAB, all my EE classes, of course.
Yeah.
Signals and systems is a big one. And then the fundamentals like of electronics, really, like or electrical engineering, I should say, V equals IR, all that business.
Yeah.
And knowing, and I took this other class, CSE 2000 something, I don't know, but it was like a digital logic design class. So like a digital logic class was pretty helpful, just conceptually thinking through things. Because we deal with a lot of like discrete parts, and just knowing how logically something might lay out is really helpful, like using gates and stuff. And because all those components are used in digital circuitry, so it helps to understand how something like a microcontroller works, because they implement things you learn in that class in a microcontroller, if you're getting into that kind of stuff. But yeah, I would say it is largely like the physics and the math that applied over to my job.
Actual
now.
like solving problems on the actual job.
Yeah. And then just like all the classes that go over the basic fundamental components, electronic components, and like things that I guess what was I gonna say? Like for work now, things that I guess I didn't realize, or that don't really transfer over, or that you don't realize when you're in class, is that like you have to pick physical parts for things, right? And so if I'm designing something, I have to pick all of the actual parts.
Yeah, you have to go on DigiKey and freaking search up a part.
Yeah, and I have to specify them. So like when you get when you're making a circuit, or you're analyzing a circuit, it's just like, here's a resistor, okay? But when you're picking a resistor, you have to make sure, one, okay, what size is it? Like, is it physically going to fit on my board? Or is it too big or too small? Okay, what's the power rating? Because these things aren't rated for any amount of power you can give them. Is it going to explode because I'm putting too much power through it?
Yeah, like stuff that's just taken for granted, like on a test, like this is just resistor R1 and it has this value.
Like, what's the accuracy of the resistance? Like, how inaccurate can I get this resistor? Like, can I cheap out on like a whatever, 15% error? Or is this something for sensing that I need like a fraction of a percent error on this resistor so I get a good measurement? Shit like that.
You have to consider money and shit too.
Yeah, how much does it cost? And components capacitors get derated in various temperature degrees. So the capacitance, like, you never think about this. You're like, oh, capacitor is a capacitor. Like, no, actually, sometimes it can have its capacitance value vary by like 20% because it gets derated by it depends, and it's because of temperature ranges. They're very responsive to that. So that's why you get certain chemistries for capacitors. Like, it gets specific. It's like, oh, well, I'm going to use a COGMPO, which is just like a specific capacitor chemistry that's stable over a temperature range, like pretty stable. So shit like that. You know what I mean? You know, like, okay, well, I have a wire, and it's a wire, but also it has like some resistance and inductance in it just because it's a wire. You know what I mean? It's like some characteristic impedance. It's just, and like, I don't know, stuff that you wouldn't normally, unless you take like a transmissions line class, which I didn't actually take, but I think maybe in EM Fields and Waves or something, I would have gone over that shit.
Yeah, where they and like I never really thought about this too, but actual like length of wire.
It matters, because
like all of a sudden, like stuff that you took as like a perfect wire is literally no longer applicable.
Yeah, it's not a thing. The longer the wire, the higher the resistance, just because it's more metal, right? So it's just stuff like that you don't think about, and picking components, like, you just kind of expect them to work or have the math work out when you're in class, but when you actually go pick them, it's like, well, because of all of these different things, it only works in this specific range. And it's like, there's like 5 or 6 things per part you have to consider when you're making something. So,
and here you are designing massive circuit boards,
Yeah.
It's a lot of consideration. It's kind of crazy to think about. Now, like, so then this has to be like, surface level because of, working for who we work for. But what does a typical day look like for you?
Oh, okay.
And I know this can vary quite a bit depending on your project. But, you know, general sense, what's like a typical day for Adam Bohr on the job?
Okay. Yeah. I mean, I guess it depends what I'm doing. If, we can break it up. So if I have just started a design and I have my requirements sheet, pretty much like, or if I have to derive requirements, I pretty much have to say like, all right, what do we need and what are like our, you know, like what can we get away with? Like how can I set my hard requirements, right? So like this is what I need the system to do. Well, I'm going to restrict it like this and that and say it's going to work in these conditions, blah, blah, whatever. If I have requirements already, basically I'll take the requirements sheet and because when you first get assigned jobs, like it's going to be a requirement sheet. You're not going to derive the requirements like in the beginning. Your boss is going to say, "Hey, I need something that does this."
Right. Especially when you're first hired, if you're a newbie.
Yeah, and like your boss isn't going to let you, you know, crash and burn. Obviously, he's going to be reviewing your stuff. So, what I'll do is I'll take a requirement sheet and I'll say, all right, how can I satisfy these requirements? How can I, and I'll draw like a block diagram. Like this is what the system I'm going to be making is going to look like. High level, okay, how do I satisfy each of these blocks? And then I'll go into each one and I'll say, oh, well, I'll do this, and that. And like, so it's really just like visualizing, all right, how am I going to actually attack this problem? Maybe there's some stuff or components, like things I don't know how to do, like, oh, how do I limit current on something? You know what I mean? Oh, well, a current limiting resistor. Okay. Like, what can I use to reduce current spikes? Okay, this kind of resistor or thermistor, like an NTC thermistor or something like that.
Yeah.
And I'm like, oh, I don't know what that is. So like I ended up reading about it. So it's a lot of reading. When you first, depending on what it is, if it's not something I've seen before, it ends up being a lot of reading. Like if I had to make a charger or something, like I got a battery charger, like I got to read about how they work and what the theory is and what are efficient ways to do it. And then I can take a crack at designing. And so it's a lot of that probably for like a week or so. I kind of plan it out in my head. Now I can kind of just jump into it. But then it's a lot of like, okay, well, now I got to pick a bunch of components and design something. So I'll go in, depending on what I'm doing. If I'm designing a circuit, I'll go through, I'll pick some parts. I'll probably simulate it. I'm not that quick with LT Spice yet, but basically just make the circuit on LT Spice and then run a simulation.
Make sure everything checks out.
Yeah, that more or less emulates what I'm doing. Sometimes I'll import certain specific components into LT Spice. You can model like exact components.
Yeah. LT Spice is cool like that. I remember using it very briefly.
Yeah, it's a very useful tool. Definitely learn how to use it because everybody uses it, and it's free. So, but yeah, anyway, so I'll simulate something, make sure it works, and then what I'll do is, I have to make footprint libraries. So I have to draw a schematic. I have to make all the components. So physically, I have to draw like what it's going to look like. And then I can import the part I selected from DigiKey into Altium and it'll automatically populate all the characteristics of the part. And then it's like almost attached to it like via a link, right? So then I can place this part on a schematic sheet. And if you click on it, it'll give you all the information about it.
Oh, so that's a really cool function of Altium. There we go.
Yeah. Yeah. So, and then I'll do a schematic capture. So I'll draw out my whole circuit. And usually I'll scratch it out on a whiteboard or on a piece of paper. I'm like, this is kind of how I think it's going to work. And I'll iteratively update it on the schematic sheet. And so I'll go through and basically what I end up doing is I end up drawing a whole circuit in Altium, like in the schematic capture. And then we do reviews. So I'll have a review and then if I'm doing a layout,
boss will be like, yeah, this is cool, but we want to actually do something like this.
Yeah. So sometimes, well, that's the thing. Sometimes they'll be like, hey, this is what I'm thinking about. So we do an architecture kind of review first where I'm like, these are my ideas. What do you guys think? And I'll be like, oh yeah, let's use this for this because it's more efficient or blah, blah, blah. And then I'll be like, okay, but what about this? And we'll have a little back and forth. And, I'm saying like, this is a circuit that I'm thinking about designing for this. I want to use XYZ concept. What do you guys think? And they'll be like, well, let's do this instead. I'll be like, well, these are the reasons why, whatever.
That's where I think being good with constructive criticism comes in, but also like being able to work with others and play nice with like not being so personal about your design, but also being confident about your design. Yeah. So there's like, this is how I designed it. I think it's going to work really well, but I'm also open to hearing like how I can improve it.
Yeah. It's true. I mean, at the end of the day, we just want it to work. So it doesn't really matter if it's, my design or it's a design that somebody else tweaked. Like, I don't really care so long as it fits in my thing and we ended up having it working.
Yeah.
So So it's cool, like literally. So we'll do like a conceptual phase where it's like architecture. This is my idea of how I kind of think I want the system to look like. Then I'll physically capture the schematic, and then I'll have a review on that. And then they'll say, well, this resistor value, actually check that because I don't know, like, this current's going to be pushed through this, whatever, and you didn't expect that, and blah, blah. Okay, cool. I'll take it. I'll go over it.
All right.
Then I have to design the actual footprints because we do 3D models. So I have to make a 3D model or import a 3D model and like make the actual hole pattern that's going to be put on the board. And following the data sheet. So a huge part of my job is reading data sheets because it's incredibly important for part selection. And so
what's the data sheet?
Data sheet is just, okay, yeah. So if you have a part, there's a data sheet associated with it, just has all the properties of that part.
Okay.
So all of the values that of interest that you would actually want to know about it.
All going to be on the data sheet.
Yeah, things like resistance, power rating, blah, blah, blah. All this curves for what it looks like when you do a sweep on it or something.
Right. It's like the breakdown of like, hey, this is the part, but like this is what's going on with the part.
Yeah, it's super important. They also give the mechanical description of the parts too. So you'll see like a mechanical drawing, which is when if you have something like a connector, you need to know the hole spacing and blah, 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 and what's the hole diameter. And then, so I'll make the part footprint too. And a huge thing is letting somebody check it because everybody makes footprint mistakes. And if you have a footprint mistake and they can't actually place a part on the board, it's super annoying. So triple check your footprint library, have your buddies triple check it. You know what I mean? It's like one of those things. But then once I make that, I can go ahead and lay the board out, which is like physically placing the parts on the board how I want to. And this is kind of like, again, like it needs to be intelligent because there needs to be some flow. This is where like it needs to be, I don't want to say ergonomic, but I'm going to say ergonomic in the sense that like the user, it should be very natural for the user to actually interface with it. If you're going to have people unplugging or plugging things, like I have to, so there's this thing called a silk screen, which is pretty much just the layer on top. That's all of the print on the board. That's like boxes and lettering that you can draw on it.
Okay.
So like making proper use of the silk screen, like if I have a bunch of switches and they do something like, oh, do I have like a truth table I could draw right on top of it that lets the person know, well, if you flip this switch and you leave this one down, this is what happens.
Right.
And if you
little indication, something for someone who hasn't seen this and they're opening it up and they're looking at this board like, oh, this is what it does.
Yeah, like LED indicator lights that you can jump out so you're not burning power when the person's done like, debugging it or whatever.
Right.
Stuff like that. So, and also how it fits in the chassis and how. So anyways, basically laying out the board.
Right.
And then the last phase is like fabrication. So if it's a job where I'm fabricating or it's been fabbed and I have to test it, I'll go in, I'll basically take the requirements sheet and I'll say like, okay, these are all the requirements. My board should be able to do all of these.
Right.
How can I test each one of them? Come up with a little test plan.
There we go. A little checklist of tests.
Yeah. And so I'll make like a PowerPoint that's basically like a checklist or like things that I should go through and test. And then I'll set up my, testing setup. I'll get a little bench cleared and I'll get a supply and anything that I need. And I'll just run through my checklist, check everything off. If everything checks out, then we have integration where I actually put my board in the system. And then we run test the system as a whole. So
that's actually really cool. So it's like, it's kind of cool because like you have your own process where, you have to think on your own, right? You're given these requirements in the very beginning and you have to think right from the get-go, how am I going to solve this? You get your list going, you start looking for parts, you start fabricating everything to come together. And then it comes time to brass tacks when we actually have to make the physical board. Yeah. And the physical board's made. Now you got to think, okay, so this has got to pass everything that I've been given. That's step one. And step two is like, oh shit, this has actually got to work with everything else. Yeah. And that's kind of the biggest jump.
Yeah, that's the biggest jump for sure because I have to make sure that I've tested my board thoroughly enough that I won't damage anything that I'm interfacing with because that sucks if that happens.
Right. And you want it to, so like if there's something that's going wrong, you can kind of have at least a larger assumption that it probably isn't your board. It might be, but man, have you checked it out so much that it would be unlikely. So maybe let's look somewhere else first and then we can check it out later. Yeah.
And like I need to be familiar enough with my design that if somebody else has a question about it, I can just answer it immediately. Like I'll get phone calls all the time. Like, oh, hey, what happens if I do blah, blah, blah. And I have to
have that answer on stat. Yeah.
So if I get a call like that, I'm like, oh shit, let me go grab the schematic and like, I forgot because I haven't looked at it in a long time. But stuff like that. And that's, you want to make sure you test them thoroughly because especially me, I'm making power distribution boards. Like I don't want to blow something up because my board wasn't doing what it was supposed to.
Yeah. That's the last thing you want to happen.
So it's kind of, yeah. So it's pretty cool. I like it.
Yeah.
Pretty involved.
Yeah, sweet. Now, as like a closing statement, is there something that maybe you would give advice to people thinking about going into electrical engineering, BME, or anything like that? Any closing thoughts, as it were?
If you're going into
BME or EE, or trying to get an EE job, or anything, any sort of advice you would give to anyone in engineering?
Fundamentals, learn how to code. Just do it.
Learn to code.
And
hashtag.
Yeah, actually though, like just do it. You're gonna have to do math, and it's not math you're gonna want to do by hand. So learn how to code.
Yep.
MATLAB's your friend. And simulation, like you just learn how to use the simulator really well because you're gonna use it a lot. And that's probably the bulk of it. Fundamentals and simulations.
Sweet. All right. That was the podcast episode.
Oh yeah.
Thanks for listening. We got current events coming up on Friday. And without further ado, enjoy.
Don't text me, I'm sorry. I let the diamonds hit. Shit talk like a story. Pop like a vitamin. Don't text me, I'm sorry. I let them diamonds hit. Shit talk like a story. Pop like a vitamin. Had to run for the bag. With the llama on my back. Snapping on the track. Eat the beats like they a snack shop. In a drop top. Haters playing with the hopscotch. Coming for that top spot on God. Out the kennel, chopper bark incidental. Diamonds flashing on the dental. Put the pedal to the metal. Like that game, twisted metal. Said I play too much, bitch, you say too much. Gave them way too much for the best of all worlds. Driving like I stole it, see me Audi A6. Tell me that she hate me, but she know I'll make it. Wanna stick around for the bag, there's no shot. Left you in the past, you're not in this plot. Don't text me, I'm sorry. I let the diamonds hit. Shit told like a story. Pop like a vitamin. Don't text me, I'm sorry. I let them diamonds hit. Shit told like a story. Pop like a vitamin.